Hello, I'm Arnold. I'm a visual effects artist. In this tutorial, I'm going to talk about how I made this waterfall effect for this Magic Market project. There are 5 parts. First, I'm going to talk about the basic flip workflow in Houdini. Second, we will build this waterfall simulation from scratch together. Third, after we finish the main body part of the waterfall, we will add some white water for it. Fourth, we will use Karma render this effect. We will set up different render paths and AOVs for us to use in the later composition chapter. Finally, I will show you some composition work in Nuke. Okay, let's get started.
Okay, let's make a geometry node first and go inside. Let's make a peak height. Let's move up a little bit. And then I'm gonna convert to a flip source first, and the node to do that is called flip source. So after we connect to flip source, we see our peak height looks like this in the viewport, and this is actually a volume. If I middle click on this flip source, you see there's a surface field and some particles in here. So in order to see the points in the viewport, hit W, and we are going to this wireframe mode. And there are a bunch of points in here. Those are particles. On this flip source node, there's a particle separation parameter. If I lower this value, I get more points. If I increase this value, I get less points to work with. And for this voxel size, if I lower this value, I get more resolution. If I increase this value, I get less resolution. Okay, now I'm gonna use a null node, call it out source. And let's build our dot network. And we need a flip object, a flip solver. Let's connect them together. As soon as we connect them together, we see there's a bounding box in here, and there are something at the center, and that is our source. But that is not the correct source. We need to let flip object know where's the actual data coming from. So let's go to subpath and pick our out source, and here is our peak. Also, right now it's displaying as a spread particle, but that is really heavy. So what I usually do is I go to guys, particles, visualization. I visualize as particles, and this is really light. And on this flip object node, we see there's a particle separation. So I'm gonna link this one to the outside. Copy parameter. Paste relative reference. And for the voxel size, if you see on this flip object, there's no voxel size in here. How do we get the correct voxel size? It's basically we need to use particle separation multiply grid scale. And these two values multiply together, and that is gonna be the voxel size. So I'm gonna also paste the particle separation in here and multiply this grid scale. And that is the correct voxel size. So now if I change the value inside, for example, particle separation, let's get more points, lower this value. See on the outside, this will auto update. Cool. And now if I play it, nothing gonna happen. That is because we don't have any force. If I use a gravity node in here, we should see something is going to happen. And as soon as this peak height going out this bounding box, it's going to disappear. So we know this bounding box defines the area where we can actually have the simulation. And if you want to change this bounding box, we can just go to flip solver volume motion. And here's the box size. So I want to make it smaller. Okay. Maybe something like this. Cool. And if I play it, and it's the same, gonna disappear. Cool. Now what if I want to make this as a closed bounding box? We can do that on the flip object. Enable this closed boundaries. Now if I play it, it's gonna hit this boundary. And we get a splash. And the color is coming from this color ramp based on speed. So if I change the color, for example, to red, now it's from red to white. Okay, and next thing is, instead just get one splash. I want my source constantly emit liquid from it, and with a node called volume source. And the soap path is the same, out source. And initialize, right now by default is using source smoke, but we actually want to use this source flip. So if I click this button in here, be careful on this part. After I click this source flip, we get something here. It's called surface. This is our surface field. And if I go to particles, I have my particle in here. Now if I play it, as you can see, this peak head constantly emits liquid, and it's gonna hit this boundary. Okay, now let's say we are happy with the result. The next thing is I need to convert these particles to mesh in order for us to render. So I'm going to use a dop import field to actually get our particle first from this dop network. And the dop network is this one, so you can just click and drag to there. And dop node is where is the data coming from? It's coming from this node, flip object 1. So I can just copy this one, paste in here, slash f, the first one, flip object 1. And preset is flip flute. So if I display this one, I should see my particles in here. And if I middle click, I can see there's a surface field and a velocity field in here. Cool. So here's our particle. And we need to convert to mesh. I'm going to use this node, particle flute surface, and display it. You can see now it converts from particle to mesh. And for this particle separation, we need to mesh this to our dop network. So I'm gonna go back to flip object, copy this one, paste to here, relative reference. Now it needs more time to cook because we have more less particle separation, more points, and we get a much better volume mesh representation. And for the voxel scale, this is determine how many points do we actually want to have. If I lower this value, I get more points. If I increase this value, I get less points. Okay, now here's our final mesh. We can render it. So here's the basic liquid setup. Before making the waterfall, I want you guys to looking for reference first. you need to understand what kind of waterfall are you gonna make. Do you want to make something like this? Really big waterfall. Or you want to make something like a small waterfall, like this. Now let's start working on this waterfall setup. Let's make a geometry node, call it setup. And I have a terrain coming from an artist called Mo Yi. He is really a great artist, and he has lots of free tutorials in here. Now let's bring this asset in here. So here is our asset. I'm gonna make my waterfall coming down from here. So it's about this wide. Also, my camera angle is like this. And there will be a market block this part. So I'm not gonna worry about this part. Also, I'm not gonna worry about this part because we are never gonna see it from the camera view. First thing is I need to convert this one as a watertight geometry for us to use for a collision geometry. But right now this is just too big. So I'm gonna actually cut it first by using some delete node. Bounding box. Okay. I'm gonna make another one to delete this part. Yeah, maybe something like this. Okay. And now I'm gonna use this extrude volume node to get some thickness. Okay, so here's our collision geometry. Let's call it alt collision geo. And for this waterfall source, I'm gonna use a box and place it maybe in here. So let's make a box. And I'm just gonna put the value in here. Size. And uniform scale is 1. So here's our box. I'm going to change type to polygon and add some divisions. Okay, and I want to have more resolution, so I'm going to use a subdivide node to get more resolution. I want to make my source more organic, so I'm going to use a point probe and add some noise. I'm going to use this AA noise and add this one to the position. Okay. Also, for this AA noise, we can actually use 4D input. So I'm going to use vector to vector 4 to convert this one to 4 dimensions. Also, let's export everything to the outside. I'm going to use time to drive this noise animation. Also, I'm going to multiply a parameter in here for us to control the animation speed. Okay. And right now the amplitude is just too much, so I'm just gonna lower it. And here's the animation speed. I don't want to make it moving too fast, so just a tiny bit. I think this is good. Okay, so next step, we need to convert this one to a source. And this time I'm going to use VDB from Polygon to do that. Now, as you can see, there are some intersection problem here. I don't want to have my source inside those rocks. I want to have a gap in here. So I'm also gonna convert this, our collision geometry, also to a VDB. That is because I'm gonna use a node called VDB combine to get rid of the intersection part. And here's the operation. The operation I'm going to use is SDF difference. So see here. Now it's cut this part from here. Right now the resolution is too low, so I'm going to increase the resolution by lower this voxel size. Also, one thing that's really important is we always want to match this voxel size, these two voxel sizes together. Otherwise, it might get a weird result. So I'm just gonna copy this one and paste to the other side and lower this value. Okay. And now this is a VDB source. Now I'm gonna use a flip source. Now after VDB from Polygon, because I want to have some particles in here. Also, on this flip source, we can set our initial velocity, and it's going this way, so it's negative x. I'm gonna put negative 2 for now. We can change this one later. And let's make a null node. Call it out source. Okay, so here's our source. Now let's build our dog network. And a flip object, a flip source, flip solver, connect them together. Let's go to flip object, change our path to our source, out source. And also change the visualization to particles. Let's link the particle separation to the outside. Do the same for voxel size. Okay. Now if I use a gravity node in here, it should just fall down. Cool. But we want to have our source constantly emit liquid, so I'm going to use volume source in here, and the path is out source, and initialize source flip. Now if I play it, it is working. But one thing is, we have our terrain in here. We want to use this one as our collision object. So let's bring our terrain into our DOP network. Let's use a static object, display it. And the subpath is going to be this out collision geo. Here's our collision geometry. But this is not an actual collision geometry. This is just a geometry representation. The actual collision geometry is we need to turn off display geometry and go to collision, volume, turn on collision get, and this is the actual collision geometry. But as you can see, the resolution is quite low. In order to get more resolution, we can increase this value, for example to 50, we get more resolution. But this way is kind of heavy. I prefer use a different way. I'm gonna go outside since we already have this VDV from Polygon in here. I'm gonna use this one as the actual collision volume source. So let's make another node in here. Call it out collision SDF. Let's go back inside on the static object. Let's go to mode, pick volume sample, and go to proxy volume. Here, let's pick this out collision SDF. And here's our collision source. It's looking really good. Now let's turn this one off. Turn back on this display geometry. And this is on the side. We need to put this one to our chain. So let's use a merge node. On this merge node, pay attention to here. Relationship is collide relationship. This one we want to use. And also this relationship, you see is left inputs affect right inputs. So if I connect like this, it means now this liquid is affect this collision geometry, and it's not going to work. What we need is we need to make sure this line is on the left side and this line is on the right side. Now this terrain is affecting this liquid. Now if I play it, you can see the collision is working. Cool. And based on our simulation, you can see the bounding box is just too big. So I'm gonna make this one smaller. Also, like I said, we don't need to carry this part. So I can just make this one really close to there. And same for this part, we don't need to carry this part. Okay. Cool. Now let's just lower this value. Let's see what we can have. I'm gonna run a flipbook. And this is what we have. And currently I think this waterfall is dropping too fast, and I want to slower this animation, and we can just go to gravity and reduce this value maybe to -4. Also we can add some air resistance. Gonna use a pop drag and attach to the second input. For this pop drag, I can just use a really small value, maybe 0.05. And this time let's increase the particle separation a bit more and see the result. For this gravity value and this drag value, I tested a lot. I have a lot different versions with different values, and I think this combination is the best in this case. And of course, if you use a different collision geometry or different waterfall setup, you always need to test your own value. Here is the result. And after watching this, I think the motion is just going one way. I want to break this motion by adding more noise into it. So we can go outside. After this flip source, we can let's visualize this velocity for now. So the velocity is always going to one way, and also this jitter seed right now is a constant value. You can use add frame. So each time we get different position to get the point. Okay, now I want to break this velocity. I'm gonna use a point velocity node to do that. Let's display it. And I want to use keep incoming and curl noise, add curl noise. So now if I play it, you can see it breaks this regular velocity direction. Cool. And I want to have multiple point velocity to break it even more. So probably this is a big noise, and the second one is gonna be a small noise. For this one, I'm gonna use 0.1. I don't want to break too much, just add a little bit of variation. And pause duration, this is how fast this noise is moving. Swirl size 0.6. This is on the y-axis. And let's make another one, point velocity. Add curl noise, and also keep incoming. This scale, let's make even smaller. Pause duration 1.2. Again, these values is after me test a lot of times to get the value that I like. Okay, now I'm gonna go here and lower this value. Now let's see the result. This is the new result. Overall, I think it's better. There are something else you can try. For example, you can go to viscosity, enable viscosity, add just a little bit viscosity and see how the liquid behave. And also you can try changing the velocity smoothing. If you think this is going too crazy and has too much details, you don't want to see too much detail, you can try increase the velocity smoothing. In my case, I think this is looking okay, so I'm gonna leave this one as default. Okay, so let's say we are happy with this result, and I'm gonna get the result in the SOAP level. So DOP import fields, and DOP network is this one. DOP node is flip object 1 preset. I'm gonna use this flip flute. Okay. Everything is working fine. It's looking good. But one thing we need to do before actually cache a high resolution is I'm gonna go back to DOP network and go to flip solver, particle motion, droplet. Let's enable detect droplet. Also go to vorticity, enable vorticity attribute. This is for us to do shading work later, and this droplet is we will get different behavior for the droplet. So if there are some points far away from the main body, it will get a different behavior. And also this is something you can test. Okay, now I'm just gonna lower this value to a really small value. For this grid scale, I'm gonna leave at 2. If I want to add more resolution, more character into it without adding too much points, I can try lower this value. But if I lower this value, even maybe just lower by 0.25, I will add more simulation time. So be careful with this value. For now, I'm gonna leave this one as default. Okay, so we can just cache it. Actually, before cache it, I'm gonna add a compress node. So this is the more efficient way to store all the data, and particle separation should be the same. So copy and paste. Everything else is the same. We need the velocity, we need P scale, droplet, viscosity. Okay, now we can just cache it. And for caching, I think we need to at least pre-roll 100 frames. So probably we need 320 frames for the entire shot. Okay, now we can just click Save to Disk. This is a quick fix. So I didn't use the old one for the collision geometry. Instead, I used this file. And the process is similar. I use a couple of delete nodes to isolate the part I want to use. And use this one, use a extrude volume to convert to a watertight geometry as our collision geometry. Okay, my cache is done, and this is how it looks like. We have lots of packed bounding blocks in here because we use this compress node. We can just use a particle through surface node to see our points. But right now, I don't want to convert to polygon, I just want to convert to particles. Okay, this is what we have. We have 7.5 million points. This is good, but as you can see, there are some problems. First, we have lots of flying particles in here, and also the collision result is not looking super good. That is because we only have one step for the simulation. You can go back and increase the sub-step to get a better simulation, and maybe you can get rid of this part. Or what you can do is we can do some post-process to fix this part. First thing, let's kill those flying particles, because if we don't do that, when we convert to mesh, we will see some flickering problem later. If I middle click on this particle through surface node, you can see we have a droplet attribute. So I'm just going to use a blast node and say at droplet greater than 0.1 and its points. If the droplet is greater than 0.1, then I want to kill it. So as you can see, before we have lots of flying points in here, and after we only keep the main shape in here, and we still have 7.4 million points. Okay, now let's fix this part. Let's get our collision geometry in here. And I can just use a group node. Points. And use bounding region. Okay, so clearly this part is in this bounding region. Let's kill this part. Blast. Group 1. Points. Okay, and this is the final particle we want to use. Now let's display the color. I'm gonna do it in the point warp. Since we have the velocity in here and also we have vorticity in here, I'm gonna use these two attributes to visualize as the color. Let's get our vorticity in here. And also the velocity. Let's compute the length. If I just use the velocity and connect to the color, this is how it looks like. Right now the range is from 0 to 12. Let's fit it. Okay, maybe 10, maybe 8. Let's say 8. And vorticity. Let's do the same, fit. from 0 to 500. Maybe that's too much. 200, 100, maybe 80. Yeah, maybe 80. And let's use a ramp. Rotate it. And that is ramp velocity. Okay. It's looking good. Let's see this ramp for velocity. Cool. Now I'm gonna add these two together and then clamp it. Okay, this is how it looks like. This is only for us to visualize in the viewport. And now, here's our particle simulation. Let's convert to mesh. Okay, and particle separation, let's link it. In this case, it's gonna be, this is a different cache, and I didn't use this simulation from this top network, but it's similar to that one. And for this one, the particle separation is 0.008, and the voxel scale, I want to get more details, so I'm gonna lower this one to 0.7. Also, influence scale is, after we convert to mesh, it's looking for how many points within the range, how many points do we want to use to convert to mesh. And influence scale, I'm gonna lower it to get more detail. Also, the droplet scale, I want to do the same, 0.5. Okay, now let's connect it. Cool, this is how the mesh looks like. Also, what I usually do is, after convert to mesh, I'm using a peak node. I want to peak based on the normal. I want to peak in a little bit to get a little bit more resolution. Just a little bit. So before and after. Okay, now we can cache this one. can just click Save to Disk. Okay, this is after we cache the mesh. Overall, it's looking good. Now let's work on this Whitewater simulation. We can just use this compressed data for us to use to convert to Whitewater source, because the only thing we actually need is the surface field. So I'm going to say a Whitewater source. Okay, maybe frame, let's say 48. And we can see something here. Or maybe frame 120. Okay, so here is our data. And this is the source. On this Whitewater source, we can use the speed to limit where we want to actually have the Whitewater source. And we can also use curvature, acceleration, vorticity, these three things for further control. And we can visualize as points if we want. So red is curvature, green is acceleration, and blue is vorticity. In this case, I don't think I'm going to use curvature. I only care acceleration and vorticity. And acceleration range, I'm going to use 25 to 40 for this case. And vorticity is 40 to 45. Okay. And speed range is 1 to 6. Cool. Let's see more points. We don't want to have too much source to emit Whitewater. And later when we run the simulation, we will see lots of Whitewater. For volume, I'm gonna use the same as the voxel size in dot network. And for this case, it's gonna be 0.016. Okay, and we can use a null node. Call it out Whitewater source. And for this one, let's call it out liquid sim. Now let's work on the Whitewater simulation. Let's build our dot network. For Whitewater simulation, we need a Whitewater object and a Whitewater solver. Okay. And we can see we have a bounding box in here. This is where we can actually have the Whitewater simulation. And we can control the size in here. And so what I'm gonna do is I want to connect this bounding box with the bounding box we have for the waterfall simulation. So I'm gonna go back to the waterfall simulation network and go to flip solver, copy box size and box center and paste relative reference to the size for Whitewater. Okay. Also, we need our collision geometry in here. And it should be the same, alt collision geo and alt collision SDF. Here, and collision volume sample for proxy volume is this out collision SDF. Let's merge it. Cool. And we don't need to have gravity for this one. That is because in this Whitewater solver, if you go to force, you can actually see the gravity is already in here. By default, it's negative 9.8. But if you still remember, when we are doing this waterfall simulation, our gravity is negative 4. So I'm gonna use the same gravity for Whitewater. Negative 4. And let's bring our source in here. For this volume source is our SDF field. So out liquid sim. This one, surface field. And emission source is our Whitewater source. Okay, now if I just play it, we should see something in here. Okay, you can see we have some points in here and it's working, but we don't have too much points. So let's get more points. I'm gonna go to Whitewater scale, lower this value. And for vector set, I always use the double value for Whitewater scale. So I'm just gonna copy paste in here and multiply 2. Okay. Also, I'm gonna turn on add state attribute. This is really important for us to use in the later. It will split foam, bubble, and spray for us to use. And left span, I don't want to make my Whitewater live too long, so I'm gonna lower this value. This is per second. This is the average life for Whitewater per second. And based on reference, I want to have less foam, so I want to make my foam die faster. And for velocity, I'm gonna introduce some noise, so just turn on add noise. Forces, this part is good. Foam, I'm gonna turn on enable erosion. Repellent, I want to make the size smaller. Yeah, I think everything else is good. Okay. And also for this Whitewater simulation, I want to introduce a little bit air resistance. So I'm gonna use a pop drag and connect to the third input. Lower this value. Cool. For this foam, for this Whitewater solver, you can find more reference at ZFX documentation website. There are lots of information. It's really cool. And also, you can check Igor's ArtStation, and he has done lots of Whitewater simulation, and you can learn a lot. Okay, I think that's everything. Now we can just cache it. Let's bring the Whitewater simulation back to the sock level. So doc import fields. And the only thing we need is geometry. Okay. Now we can just cache this one. after I finish the cache, this is how the Whitewater simulation looks like. Cool. In order for us to render Whitewater, we can render it as point or we can render it as volume. In this case, I'm gonna render it as volume. So I'm gonna rasterize it. Volume rasterize attributes. But for this node, it's looking for a density attribute. Currently, we don't have density attribute, so let's make one. I'm gonna do it in the run goal. F at density equal to 1.0. Now we actually see it converted to volume. I'm gonna lower this value to get more resolution. Okay, but right now all points are sharing the same density value. I don't like it. What I want to do is I want to change the density based on the surface, based on the match surface for the Whitewater. So I'm gonna go back to run goal, and instead using this constant 1.0 in here, I'm gonna type something else. F at density multiply equal. I'm gonna use a ramp to control it, and the ramp, because we are doing this based on the surface distance, so I'm gonna call it surface ramp. And based on depth range. And as you can see, we do have these depths in here, but right now the depth is not from 0 to 1. So if you go back to file and check the geometry spreadsheet depths, and the range is actually from negative 0.25 to 0.4. So let's remap it. Fit. I'm gonna create a slider, channel float. Old min and old max to 0 to 1. Okay. And old min is negative 0.25, old max 0.4. For the ramp, I want to have the most density part near the surface and almost no density at all below the surface or above the surface. Something like this. And now this is how it looks like. So before and after. Okay, let's get more resolution. Cool. Turn on velocity blur. It will look better when we render it. Blur sample. Everything is okay. Okay, now if I go to material palette and search Whitewater shader. On this shader, as you can see, we can actually render the reflection of our Whitewater. But in order to render reflection, we actually need a gradient field for us to use to render the reflection. Now let's get this reflection, the gradient field in here. VDB analysis. And custom, I want to compute gradient. the density, and now we get this gradient in here. Let's merge these two together. Now we get density and gradient, but currently the gradient is reversed. So let's reverse back to the correct direction. VDB combine. I can just multiply by -1 to get the correct direction. And this is our Whitewater sim. Let's render it in Karma. In order to render it in Karma, we need to go to Stage. I'm gonna change my workspace to Solaris. And let's go to Stage. Let's use a sub-import lab to get our waterfall mesh. And we see it's in here. And here's our scene graph path. Right now it's called sub-import1. It's reading the name of this lab. I'm gonna change it to waterfall. And now you can see the name changed to waterfall. Also, I'm gonna change load as reference. This is a more memory efficient way to load in our data in here. And here's the printing path, $OS. Because of this project, it's called Magic Market. So I'm gonna change the name to Magic Market. And now it's called Magic Market. Also, this is an effect, so I'm gonna put this one in an effect layer. Also, it's waterfall and body. So in the scene graph tree, you can see here's the Magic Market, effect, waterfall, body, and surface. Cool. Let's do the same for Whitewater. Okay. I'm gonna replace this one actually to $OS. Let's do the same for this one. Okay, now here we have a waterfall and also we have a Whitewater. Finally, let's get our terrain in here. Okay, we don't have our terrain ready, so I'm gonna go back to objects. Let's give this one a null, call it alt terrain. Cool. And for the terrain, this is not a shouldn't be in the same effect layer. Let's create a new layer and maybe call it environment. Okay. Now let's add a camera in here. Something like this. Okay, now let's add a dome light. I'm gonna use a HDR texture. Probably let's use this one. Since this is a night shot, So I'm gonna modify the color to a bluish color. Let's render this one. Let's see what we have. Click this button and let's go to Karma Beta. Okay, the light is too strong. Okay, the render is working. Now we need assigned material for terrain, and also we need two materials, one for liquid and one for white water. Let's use a material library lab in here. And you can double click, go inside. We need a principal shader for terrain. Maybe something like this. Also, I'm gonna create two more shaders in the material palette. One is the basic liquid, and another one is the basic white water. I'm just gonna copy these two and paste in here. Okay. Now let's assign the shader to our geometry by using a assign material lab. Okay. Now we need three materials in here. For the primitive path, this one I'm gonna use this terrain. And material path is terrain. Okay. Now you can see it is working in the viewport. And next one, let's do this waterfall body, basic liquid. Finally, let's do this white water, basic white water. Okay. Now let's render it. Clearly, the material is working now. Now let's tweak the shader. Let's go back to material library. I'm gonna work on this white water first. I want to see more white water, so I'm gonna increase the density scale, maybe to 10. Okay. Because the white water is basic water, so I want to get more light. Now let's go to basic liquid. Let's stop the render. For this vorticity to diffuse intensity, if you still remember this one, we did in here. We used vorticity as our color ramp to see it. And this is our range, 0 to 80, and we can use the same one in the shader. So I'm gonna turn on vorticity to diffuse intensity, and it's from 0 to 80. The interesting thing is, even I set to 0, but we still have some values after we added the intensity. That is because the ramp, if you see it on the very left, the default value is 0.1. However, I don't want to see any of the color introduced to the shader if there's no vorticity. So I'm gonna set the value to 0. Okay. And everything else is good. Let's render it one more time. Now the water is too blue. Let's go back to the material. As you can see, this is using base color, but color is actually blue. I want to change the color to white, because in the real world, the color for water should be white, and the blue is coming from light. Now it's looking much better. Okay. Now for final output, we can use a karma loop at the very end. And on this karma loop, we can specify which camera we want to use and where we want to export our picture. And we can set pixel sample limits in here. Okay, here's our camera, is good. File, render, I'm gonna call it $OS dot $f.exr. Pixel sample 128 is too much. Maybe 36 is good enough. Also, for these indirect samples, I prefer use distributed, so I have more controls. If I just click render, everything will be rendered. But what I want is I want to have two paths, one for the terrain and one for the waterfall. So for this one, I'm gonna call it waterfall beauty. Okay. And let's use a render geometry setting before the karma loop. Okay, in order to render the waterfall as itself, we need to set our terrain layer as a matte. So terrain goes to here. Let's turn on its matte. Let's see what we get. Okay, it is working. Let's stop the render. Cool. For the waterfall, since we don't have SSS, so I'm gonna set this one to 0. Volume sample 4 is good. Volume limit, maybe 1. Refraction limit, I'm gonna set to 10. Reflection limit, maybe 8. Also, for the velocity blur, we need to do it in the render geometry setting first. And it's gonna be this body. Let's enable the motion blur. Also, let's enable motion blur in here. Velocity blur. Cool. Here's the waterfall path. Now let's do the other one, terrain. This time, I want to use this body as a phantom, but I don't want to render the volume. So I'm gonna set the volume to off for now. Whitewater, and render visibility is off. And let's make another one. This is waterfall body. This time should be a phantom. Okay, let's see what we have. Cool, it is working. For this one, we don't need volume sample. Also, I'm gonna set volume limit to 0. Refraction, there's no refraction. Maybe we can increase the bounce for diffuse. Okay. If you want to have more AOV for each of them, you can, for example, go to Waterfall Beauty and go to Image Output, and here you can have all different AOV in here. Maybe these two. Okay, now the only thing we need is to hit render to disk. Here I'm just gonna render one frame, but for you, you can set to render frame range and pick the frame range you want. Okay, after we render the image, we should have two pictures. Let's get them in here. Since I render 720p, so I'm gonna set the project to 720p. Okay, and let's just a shuffle. Okay, so here's our waterfall. And this is our terrain. Let's put them together by using a merge node. Cool, here's our final result. Well, if you want to use others layer, for example, you want to see what others layer we can use, you can use a layer contact node. And here are all the layers for waterfall. And here are all the layers for terrain. Okay, so after this merge node, I'm gonna introduce a little bit blur. Okay, and we can change the brightness. Maybe let's make it whiter. Okay, and also we can just make the center part brighter. I'm gonna use a radio node. And I can use this one as a mask. And we can reverse it. Cool. Now we can also introduce some green. right now I think this is too much. Something like this. Okay, and now we can export this picture. Final render dot JPEG or PNG. Hit render. And this is what we get. Okay, this is everything. I hope you guys like this tutorial. If you have any question, please let me know.